Get ready for Breakout EDU, Shipwreck, Introduction to Computational Thinking. The story. Scientists are on an expedition to locate a centuries-old lost shipwreck in the Caribbean. While searching, the scientists discover the perfect coral reef, full of many types of ocean species to anchor at. They put on their diving suits and get ready to do a little research. Little do the scientists know what they are about to see farther down when they dive in. They have discovered the famous lost shipwreck. The only problem is that the shipwreck is surrounded by sharks. The only way they can photograph and explore all the artifacts from the shipwreck is to get back to the boat quickly and safely and retrieve the shark repellent to scare away the sharks. For this activity, you'll need all of the Breakout EDU equipment that is shown below. Set the locks. The 3-digit lock will be set to the code 253. The 4-digit lock, 1217. The ABC lock, the word fish. The directional lock, up, left, down, left, up. And the key lock will be found under a chair in the room. For this activity, you will need a device or tablet with a QR reader on it, as well as printing out the resources that are shown below and the puzzles. Some of them can be put on the wall or they can be placed on the table. Print out the abstraction puzzle, which is the phone with the text message on it. With the invisible ink pen, you will circle the word fish in each one of the text messages that is shown below. Inside the small breakout box, you will put the UV flashlight, the 2 hint cards, and the abstraction puzzle that has the word fish circled with the invisible ink pen. Put the 3-digit lock on the small breakout box. On the large breakout box, inside you will put the printout of the shark repellent, the poster or sign that talks about computational thinking, and the sign that says "We did it." On the breakout box, you will put the hasp, the word lock, directional lock, 4-digit lock, and the key lock. You can print out these resources and place them around the room. Some of them can be placed on a table as well. The pattern puzzle, decompose puzzle, algorithm puzzle, and the key lock, where in the world puzzle. The game flow. For the 3-digit lock, the code will be 253. In order to solve this, the puzzle will be placed on a table, and on there's patterns that are given. For example, 4, 6, 8. So what is the rule to that? It's +2. So for the following puzzles, it will have -5 + 3. So the code is 253. Inside that box, when it's open, they'll have the UV flashlight and the hint cards. Next, inside there will be this puzzle, the abstraction one as well. The fake phone text, it has on it different pieces that are the same. For example, the fish are, and then they have to use the riddle clue here to figure out that the word is going to be fish. The UV flashlight will also show that the word fish is circled. The 4-digit lock. The code will be 1217. The QR codes can be placed on a wall next to each other. The student will scan the QR code and then it will take them to a jigsaw puzzle of each one of these posters. Once they put it together, they use their decomposition in order to figure out that the number that goes with all of these different ways is 12 and this one is 17. For the directional lock, which will be laid on a table, the algorithm directions are given to get from the shark all the way back to the boat so they can get away safely. For those directions, up, left, down, left, up. For the key lock, students will scan the QR code that is along the wall or on a table, and it will take them to this puzzle. If they click on the word world, they will get to a map that will tell them to look under a chair. Once students have solved all of the puzzles, they will get to inside of the breakout box the shark repellent that they need to scare the sharks away, as well as their "we did it, the sharks are gone and we can explore the shipwreck" sign. This then leads into the discussion of what is computational thinking and what are all of these terms: decompose, abstraction, pattern matching, and algorithm. And then you can go from there.